Hey Mech Warriors, welcome to Bad Ben's Battletech. I'm Bad Ben, and this is part 2 in our series of solar system generation according to campaign operations. If you haven't watched the first video, I would suggest going back and watching the first video first. It's just really an intro that talks about what we're going to be doing, how we're going to be doing it a little bit, the steps we're going to be taking. Now we're going to actually get into the doing. So, we're going to start with our cheat sheet, with my cheat sheet that I have here. Roll primary star, first step. And you can see actually I have the pages, page 99, 100. The rolling's actually only on page 99. This is a super easy dice roll. This is just 2d6. And if you're looking at your copy of Campaign Operations on page 99, you will see the primary generation table. On the primary generation table, there are 3 columns. One is realistic, one is life-friendly, and one is hot stars. The next table over that says seller subtype will be a second roll that we do afterwards, after we find our primary star type. It's completely up to you which of these columns you roll in, whether it's realistic, life-friendly, or hot stars. If you're making a solar system that you want to have a habitable star in, then do it on the life-friendly. If you just want to do realistic, do it there. It's completely up to you. And honestly, you don't need to roll this at all. You can simply pick which star type you want. That really, it's not important to roll. So if you have a certain solar system in mind of the way it's going to be and what kind of star it is, just pick which one you want. It describes these different types of stars in well, right beside it says star type in the book, right next to the primary generation table. So if you want to know more about the stars, just read that. I'm going to roll. I'm going to roll on the life-friendly column because I want a star with a habitable planet in it. And that's actually another thing that they tell you in the book, that you don't need to roll for. If you want a habitable planet in your solar system, put it in there. Just put a habitable planet. You don't have to create, star system after star system looking for one that rolls a habitable planet that you want. Just put it in there. I'm going to roll, but just to let you know, I'm probably going to fudge a lot of my rolls just to make this tutorial more comprehensive. I don't want to end up with a solar system full of only gas giants. That would be a bad tutorial. So I'll roll. Oh, look, I got a 8. Actually, I did actually roll an 8 on the life-friendly column, and if you look, it says G. So we have a G. Secondly, we need to go to the next table, the seller subtype. It says roll 1d6. I rolled a 5, and that gives me an 8. So it is going to be a G8. And that is the first thing that we can enter on our table here. Spectral class is going to be G8. It's going to be a G8 5. V5 is in Roman numerals. They go into long explanations. Every star type that you roll will be a G8, will be a 5, and that just means it's in its main portion of its life. It's not very young. It's not very old, and you don't need to put the V on at all. It's just, yeah. read the book if you want. So, what do I do with G8? G8, we go to the next step. What does the next step say? Record the solar survey. So we go down to page 100, the next page in the book, and you can see in the most left-hand column it says spectral class. And I'm going to scroll down and I'm going to find, it says G8V. Every one of them says V for 5, as I sort of explained. And then I'm just going to start copying all this information into my table here. So it says charge time is, for a G8, 189. That's in hours. Transit time is the next one over, and that is 6.19. After that, we have safe jump distance. That's how close your jump ship can get to the star, and for me it will be 700,990,261 kilometers. Mass in relation to Sol is 0.8 for me. All this information is going to be different for you depending on which star class you chose. Then we have luminosity, which will be 0.65 for me. After that, we get the radius. The radius is 0.93. Temperature. Temperature 5,120. After temperature comes lifetime. In million years. So this says 15,012.49 million years. We actually won't need that information whatsoever. And the last column is going to be habitability. I have such a hard time with that word. Habitability modifier, which for this star happens to be a 0. That's a modifier that you're going to need later on. Next, we're going to go down. I say down because I'm using the PDF on another computer here. We go to primary solar stats table continued on the next page, 101. Go down, find your star. I have a G8. And here what I want to record is the distance, the inner life zone edge distance from star in astronomical units. Okay, this table can be a little tricky. But if you look, G8 star has an inner life zone edge of 0.471 astronomical units. So 0.471 is my inside edge. The outer life zone edge is going to be 0.958. 0.958. And then comes our very first calculation, which is a very easy one. It is simply the outer life zone edge minus the inner life zone edge. So, it's simply 0.958 minus 0.471, and that gives me 0.487, and that is going to be the life zone width that I've already forgotten the number. 0.487. That's something that comes up later. So we have our solar survey finished. That's just copying straight out of the book. You want to get all this information down. A lot of it is important for later. What's the next step? Roll orbital slots, page 102. So we go to the next page in the book. Orbital slots, and you have the orbital placement table. This is simply a 2d6 roll, no modifiers. As far as I remember, did I record anything? Roll orbital slots. 2d6 plus 3. That's right. So that you'll never have less than 5 planets, and the maximum will be 15. So 2d6 plus 3 is going to be the number of orbital slots. I'm going to roll, and wouldn't you believe it, I got an 8. Exactly the number I wanted. So I'm just going to come over here. I'm going to type 1, 2, 3, 4, 5, 6, 7, 8. Those are all of my orbital slots. And that is it for that step. Next step, calculate the distance of each slot. All right, now we get into the first little bit of math. If you go on into your campaign operations book on page 102, and you see the orbital placement table beside each slot, it will have a number. So, for example, beside slot 1, it says 0.4. And we need to calculate the distance of each of our slots based on these numbers. And it's going to be the stellar mass multiplied by the orbital slot base location. And that is the number in the table. This is pretty easy. So orbital slot number 1, it says 0.4. My solar mass is 0.8. So it's pretty easy to do. We just do 0.4 times 0.8 equals 0.32. And that is going to be the distance to the first planet. 0.32. Move on to the next one. Times 0.8 equals 0.56. 0.56. Next one is 1. And so I can say that is going to be 0.8. No need for calculation. 1.6. 1.6 times 0.8 equals 1.28. Astronomical units. If you don't know what an astronomical unit is, it is the average distance between the Sun and the Earth, and it is used in astronomy to measure large distances. So number 5, we have 2.8 times 0.8 equals 2.24. Number 6. Whoops, sorry. I won't talk the whole time saying every number. If you have the book, you can see the numbers. That one's easy. And the last one is not easy. So that's that step done. Distance from each object to the Sun. Done. Life zone planets and inner system. So now we have enough information to tell us which planets will be in the life zone. Our inner life zone is 0.471. Outer is 0.958. Any that fall in between. Oh. Sorry, my mouse has like this extra wheel on the side, and sometimes my finger hits it, and the whole thing just shifts off to the side. And it's annoying. I apologize. So, have a look. 0.32. In the life zone? No. That's less than the inner life zone. 0.56. Yes, that's within our life zone. 0.8. Also within our life zone. So, and then what do we have? 1.28? No, that's farther away than our outer life zone. So that is going to be no. And the rest of them are definitely no, because they're even farther away. So we have 2 planets within the life zone of this star. If you want to put a habitable planet in this system, it's going to be need to be in orbital slot 2 or 3. So you're going to need a terrestrial in orbital slot 2 or 3. This also marks the inner solar system and the outer solar system. Why is this important? It's going to be important for the table when we roll our object type soon. It's also important for transit times. Transit time. That's one of the columns on the primary stats table. And to understand what is transit time is the time it takes for a jump ship to get from the jump point to any of the planets in the inner solar system. I'm just going to take a minute to talk about transit times, because there is a section in the book right here. You'll probably see it here, and it says transit times. It's on this page. It tells you a method for calculating not the transit times, but the transit distance to every single planet. I'm not going to do that. That's not important. The only important transit time really is going to be this one. That's the transit time to any of these planets, any of these 3 planets in the inner system. And that is going to be the planets you want to visit 99% of the time, because nothing out here will ever be habitable, and it'll be a very special case to want to go there and to need to know the time it takes you to get there. And the way I think of this is like, like a chart of the ocean. It doesn't tell you on the chart every single distance and time to get from every place to every other place already on the chart. You do that when you want to go to that place, and if that information is important to you. I'm not going to be doing it because it's a lot of extra math and it is completely arbitrary. They also tell you a way to calculate the distance or the average distance between any 2 planets. Also, something you really only need on a need-to-know basis. So that's all I'm going to talk about with transit times. And no, sorry, one last thing. If you actually want to calculate transit times, you need the strategic operations book, because the calculations in campaign operations will only tell you distances, and times are more complicated with jump ships. I think probably different jump ships travel at different speeds, or even the same jump ship can travel at different speeds itself. I really don't know. So that's why I leave transit times out of this altogether. The only transit time that is important is this one down here. So we have the life zones figured out. Roll objects and stats. All right, goody. We get into some of the fun stuff. What do we have? We're going to be filling out this column here, the type column. And this is going to be on page 103. So go ahead, move on to page 103, and you will find the object type table. It's a bit of a confusing table, but it's not actually so difficult to understand. We have, for right now, to get the object type, 2 columns are important. It says inner system 2d6, outer system 2d6. And this is, we're just going to roll 2d6 for any of the planets in the inner system, which is anything, the first 3 planets will be rolled on the inner system column, and the next 5 planets will be rolled on the outer system column. And it's really easy. There's no modifiers that we need for these rolls. We can just go ahead and roll. And wouldn't you know it, I got a 5, and I got a... If you look, a 5 in the inner system, it says dwarf terrestrial. Dwarf terrestrial. Next roll, it's second planet, so it's also on the inner system. Next roll, oh look at that, I got a 4. So we're going to put in asteroid belt. Number 3. Ooh, this is important. Yes, I got a 7. Terrestrial. As you probably understand, I'm kind of fudging the numbers. So that's the inner system taken care of. We have dwarf terrestrial, asteroid belt, and terrestrial. You know what? I'm going to re-roll for the asteroid belt. I don't want an asteroid belt there. And you can absolutely do this. You can. They tell you in the book, just fudge the dice if you feel like it. It really doesn't make a difference. For the purpose of this tutorial, I'm going to roll again. And look at that. I got an 8. That's a giant terrestrial. That'll be a little more interesting at that spot because it is also in the life zone. And it is possible that a giant terrestrial becomes habitable. Unlikely, but possible. So now I'm on to space 4, and this we will be rolling on the outer system. Again, 2d6. Oh, look at that, I got a 4. There's my asteroid belt there. Next, another roll, and I got an 8, which is a gas giant. So, gas giant. Roll again. Look at that. This one's going to be empty. 1 or 2 more rolls. What do I got? Oh, it's going to be an ice giant. Still rolling on that outer system. I got an ice giant. So we have that. And last but not least, a terrestrial. So another terrestrial all the way out in the outer solar system. And here we have a good spread. We have one of each. We have 2 terrestrials. So we'll be able to do a lot of calculating and doing all of the conditions that come up in this book, or as many as we can cover, with what we have. So that's all of we know now what is in our solar system. Next, we'll go here. What does it say? Roll, object, and stats. Okay, so there's actually a lot more to roll on this table. And this is where it starts getting mathy. But this part, actually, this isn't so bad at all. So I'll bring my calculator up here. We're going to first be doing, we'll be doing diameter. So if you look on the object type table, you have 2 columns, base diameter and diameter modifier. The base diameter gets added to the diameter modifier. And the way this works, what do I have first? Dwarf terrestrial. So we will go to the row for dwarf terrestrial where it says diameter modifier, and it says 3d6 times 100. What does that mean? It means we roll 3d6. I got 9. So we take a 9, we multiply by that by 100, so we have 900, and then our base diameter for a dwarf terrestrial is 400. So it's going to be 900 plus 400, which will give us a diameter of 1,300 kilometers. Actually, we probably don't need the calculator for the diameters. When we get into densities, that's when it gets really mathy. Next object, what do we have? Giant terrestrial. So we go over to giant terrestrial. It says 1d6. Roll it. I got a 4 times 1,000. So we're working with 4,000 plus 12,500. And that gives us 16,500. Next is terrestrial. What do we need? 2d6. I got an 8 times 1,000, meaning we have 8,000 plus 2,500, giving us a total diameter of 10,500 kilometers. Moving on, asteroid belt. Diameter of asteroid belt is not applicable. Put an NA there. You can do the diameter for any dwarf planets that you might get in your asteroid belt. I won't be doing that. But otherwise, what's the diameter of an asteroid belt? Moving on, we have gas giant. So we'll move over to the diameter. 2d6. I got an 8 times 10,000. So we have 80,000 plus the base diameter of 50,000 is 130,000 kilometers. Next, empty. Not applicable. Oh, that's wrong. Don't need a diameter of empty. The reason I keep this empty in the chart, the column, is, well, you can just take it out. It's really not important. But it's important to remember which orbital slot each planet is in. So my 7th planet, or no, I should say my 6th planet, the ice giant, is in the 7th orbital slot. And that determines the distance. I just keep the empty here. Doesn't matter. It's easier. Moving on. Ice giant. What do we have? 1d6. So, ooh, a 6. I got a 6. 6 times 5,000 is going to give us 30,000, plus the base diameter of 25,000. This is a diameter of 55,000 kilometers. Last but not least, our terrestrial, roll 2d6. And it's going to be 4 times 1,000. So 4,000 plus the base diameter of 2,500 is going to be 6,500. That's the diameters. Moving on, we go to density. Now, we're going to get a little mathy. Start with our dwarf terrestrial. This one's easy. This one's super easy. It is the easiest roll. 1d6. Wow, I got a 6. This is going to be a dense planet. 6. Giant terrestrial. Another pretty easy roll. It's going to be a 1d6. I got a 2. Plus 2 is going to be 4. His density is 4. Terrestrial. All right. Here's where it gets weird. To find the density of a terrestrial, we're going to take 1d6 to the power of 0.75 and add that to 2.5 to find our density. So I have 1d6. I rolled a 6. Come over to our calculator. Come on. And I have 6. That's my roll. Okay. Exponent. What is it? 0.75. 3.8. It says in the book, do not round density values. Don't round the density values. Does it want me to take this entire thing? I don't know. 3.8 is enough. We don't need a bigger number than that. We add to that 2.5, as it says in the book, and we get a density of 6.3. That's dense. That's a dense planet. Asteroid belt. So, in the book, if you look at density for asteroid belt, there is a calculation there. I don't know if that's supposed to be the average density throughout the whole asteroid belt, or if you go and visit one particular asteroid, that's how you determine the density of it. I think of it as that's the average density. So we're going to do that. And it says 1d6. Oh, this guy got a 1. So it's not a very dense one at all. And in this one, what do we have to do for asteroid belts? It is going to be 1 to the power of 1.15. 1. If it was a 2, it would be different. That would be our density now. But since we rolled a 1, 1 times itself as many times as you want is still 1. So this is going to have a density of 1. A very light asteroid belt. Maybe not great for mining. Who knows? Gas giant, moving on. Gas giant density. Oh, this one looks complicated, but it's really not bad at all. So it says 2d6. Roll your 2d6. I got a 10. 10 divided by 10 is 1. That's really easy. If you get something else, for example, you get 7. It's going to be 2d6 So my 7 divided by 10, giving me 0.7 plus 0.5, which would be 1.2. In my case, I rolled a 10, so it's going to be 10 divided by 10, which gives me 1, plus 1.5 gives me a density of 1.5. It's not difficult, you know. Just any roll you get, whatever it is, just divide it by 10. So if it's 6, you're going to have 0.6 added to 0.5. Gas giant. That's actually, from my experience, a pretty dense gas giant. It's going to have a high gravity. Empty. Not applicable. Ice giant. Density. It's really similar to the gas giant. You can see, but instead of adding 0.5, we're going to be adding 1. So 2d6, I rolled a 7. So 7 divided by 10 is 0.7. Plus 1 gives me a density of 1.7. Terrestrial, we did this one already. It's going to be 1d6. Oh, I got a 1. Don't need to do that. 1 to the power of 0.75. Is that? It's still going to be 1, isn't it? 1 to the power of 0.75 is, yeah, it's just 1. Plus 2.5 gives us 3.5 as the density. Now the last thing we roll on here is going to be the day lengths. So starting with our dwarf terrestrial, come over in the book. Day length for dwarf terrestrial says 3d6 plus 12. So I roll 3d6. I get 5 plus 5 gives me 10 plus 12 gives me a 22-hour day. What do we have next? Giant terrestrial is simply 4d6. 5 plus 6 is 11. An 11-hour day for the giant terrestrial. Terrestrial, 3d6. 6 plus 4 is 10. Plus 12 is going to be a 22-hour day as well. Asteroid belt. Asteroid belt has a day length? Each individual asteroid has a day length. This is not applicable at all. Because telling one day length of one asteroid, you know, in this chart isn't helping anybody when there's going to be millions of them. Gas giant. What do we have? 46. Roll 4d6. I got 6 plus 8 is 14. 14-hour day. Empty, also not applicable. Ice giant. Also 4d6. 8. 12 plus 3 is 15-hour day. Last one's going to be the terrestrial, which is 3d6. I got 6 plus 7 is 13, plus 12 is going to be a 25-hour day for our 8th planet. So this is all. That is the next step finished. Roll objects and stats. Next we move on to asteroid population. Now we're going to get into some math. Asteroid, what page did that say that was on? Asteroid population, page 106. Skipping a lot of the stuff. So move on to page 106, where it says asteroid belts. And here we see we're going to get an asteroid population multiplier. The way that we do this, this is a good calculation. I like this one. The way we do this, we do have 1d6 in the calculation. We also have the belt orbit in the calculation. This is one of those calculations, you might want to have a pen and paper for just jotting down some numbers. So, belt orbit. We need to find out what is the belt orbit. Asteroid belt. His distance is 1.28. So that's going to be that number in this calculation that you see in the book and that you see here. Belt's orbit we need, and what did I say? 1.28. So we'll start by adding 1.28 for the belt's orbit. And that's going to be divided by 2.8. Giving us this number. This is a number you probably want to jot down because we're going to need to move on to the next part of the calculation. Now, we have 1d6. Now you can roll 1d6. I get a 3. Oh, that actually makes it quite easy. I'm going to roll it again. Oh, I got a 4. So we're going to take 4. And you look at the calculation here in your book under asteroid belts for the asteroid population modifier, 1d6 divided by 3. So we're going to divide by 3 equals 1.333 squared. Squared. So we have 1.7777 continuing. And we multiply this. Right? Hey. There we go. By the first number, which if you have this, if you're on Windows and using this calculator, this can be really useful for having to go back to old numbers. We can select the whole thing. Select the whole thing. It really doesn't matter. You can just select it here. Copy. Paste. Now we have the calculation, which is the square of 1.332, which was 7, times this, and it gives us 0.8, right? So that is our asteroid population multiplier. I think I did that right. Let me just see that again. The last part, 4 divided by 3 equals, and we square that, right? No, that was wrong. It's right. Giving us our multiplier of 0.8. So we got to remember 0.8. It's a lot of steps just to find the multiplier. Now, what we do in the book under asteroid belts, you go to where it says dwarf terrestrials 500 kilometers plus diameter 4, medium asteroids 100 to 500 kilometers diameter 200, small asteroids blah 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 1,200,000. So we take each of those numbers. 4 is the first for dwarf terrestrials. This will tell us how many dwarf terrestrials, and we multiply that by 0.8. So we have 3.2. I'm going to round down. Oh, we're going to have to go all the way over here to asteroids. Oh, where's my asteroid belt again? It's in, yeah. So asteroid population. Dwarf terrestrials, we have 3. Medium asteroids, we take the number 200. 200, that comes straight out of the book beside medium asteroids, and we multiply that by 0.8. And we have 160 medium asteroids in our belt. And how many small asteroids? So we have 1.2 million right? Multiplied by 0.8 equals 960,000 small asteroids. So 960,000 small asteroids. Now we know how many asteroids are in our asteroid belt, and how many of those are dwarf terrestrial planets that you could then possibly go visit. You can now do all the calculations for these planets if you want on a different table down here. You know, of their density and gravity and escape velocity, blah, blah, blah. I'm not going to do any of that. That's not important. The only thing that's important to me is we have 3 dwarf terrestrials in our asteroid belt. Everything else is not an asteroid belt, and so it is not applicable. And so I will just fill that out. Everything else is not applicable. Asteroid population done. Roll for moons and rings. Ah, this is one of my favorite parts. I love moons and rings. What page does it say roll for moons and rings? Page 107. So go over to page 107 in your book to the moon generation table. Now this looks like a crazy amount of information. But it's not bad at all. It's actually a lot of fun. It's a lot of rolls. So we need to know what's in our first slot, and we have a dwarf terrestrial. So we come over to our table, and you see on the leftmost column you have dwarf terrestrial. I have all the different types of planets: dwarf terrestrial, terrestrial planet, giant terrestrial, giant gas giant, ice giant. On the very top, you have numbers 1, 2 for the next column, 3, 4 for the next column, 5, 6 for the next column. This is pretty easy. Start with first planet. So I have a dwarf terrestrial, and I roll 1d6. I got a 2, meaning I am going to roll from the 1, 2 column for a dwarf terrestrial. And it is the first planet in the book right underneath where it says 1 and 2, and you can read it. It says in this column 1d6 minus 5 medium. And that means we roll 1d6. I got a 5. We minus 5 from that roll, and know that I have 0 medium moons. If I know I have 0 medium moons, I also know I have 0 giant moons. It's not in this equation. There is no equation. There is no roll to get giant moons for a dwarf terrestrial in this column. So we're going to start by going 0 giant, 0 large. I got a 0 for my medium, so that's going to be another 0. Oops. 0. And the next roll is 1d6 minus 3 small. Oh, I got a 1. So that's a 0. He has this dwarf terrestrial has absolutely no moon. 0, 0, 0, 0 equals 0. There's no roll for rings for a dwarf terrestrial anywhere. So that one's done. Moving on, the next we have is going to be giant terrestrial. Giant terrestrial. Roll 1d6 to see which column we'll be rolling in. 4. So that's going to be the middle column. Giant terrestrial. 1d6 minus 4 large. All right, so I already know I have 0 giant moons around this one. I can already put a 0. 1d6 minus 4 large. Ah, I got a 3. It's going to be another 0 for that. Where am I? Giant terrestrial. 1d6 minus 3 medium. Oh, I got a 6. Minus 3. has 3 medium moons. 1d6 minus 2 small. I got a 3. 1d6 minus 2, that means he has 1 small moon. Total of 4 moons for the giant terrestrial. That's not bad. Next one we get is a terrestrial. I'm going to roll 1d6. I got a 1, so I'm going to roll in the 1 column for terrestrial. And it's only one roll. It says 1d6 minus 5 large. If I don't get a 6, it has no moons. Oh, unbelievable. I got a 6. He gets 1 large moon. It's 0 giant, 1 large, 0 medium, and 0 small to equal a total of 1 moon. What do we have next? Our asteroid belt doesn't have moons. They don't get moons. After this, I forget what we have. After the asteroid belt is our gas giant. Oh, this is good. This is fun. Chance for rings, probably. So I roll 1d6. I got a 3. Come over to the 3-4 column for a gas giant. Ah, no giant moons. Okay, whatever. So I have 0 giant moons. It doesn't have a roll for giant moons, so it doesn't get any in this column. 1d6 minus 3 large. I got a 5, so that means he gets 2 large. We have 1d6 minus 2 medium. I got a 3, meaning it gets 1 medium and 5d6 small. So what do we have? We have 10, 13, 16, 16 small. And that equals how many? 16, 17, 19 in total. Next up, we have our empty. Like always, not applicable. After that, we have an ice giant. Roll 1d6. 1. Ice giant in the 1-2 column. 1d6 minus 4 giant. I get a 6, meaning he gets 2 giant moons. 1d6 minus 3 large. I got another 6. He gets 3 large moons. And 2d6 small. No mediums. So put 0 for medium. 2d6 small. 8. So 13 in total. And you know, if you understand how these tables work, you know, after I do 1 or 2, and you don't want to watch me fill out the whole thing, just skip ahead. Of course. The last one is going to be a terrestrial again, and we'll roll 1d6. Oh, it's a 1 on the 1 column. Did none of my... I made a mistake. I forgot to roll for rings for my gas giant. Gas giant. It says 4 in 6 chance of rings. So the way I interpret this is if I get a 1 or a 2, no rings. If I get a 4 to a 6, that's rings. So I got a 4. He gets rings. I do that often. I forget the rings. Yeah, the ice giant didn't get a chance for rings there. Terrestrial, we rolled. Did I roll already for the terrestrial? I forget, guys. I'm gonna roll again for the terrestrial. I got a 6. So we go in the 5, 6 column. It says 2d6 minus 4, 2d6 minus 4 for for small. 2d6 minus 4 for small. So I got a 5. That means he gets 1 small. Oh, actually, it would be 0 giant, 0 large, 0 medium, and 1 small, equaling 1. This terrestrial planet actually has a 1 in 6 chance of rings. I think that's the first time I've ever gotten a terrestrial planet that could have rings. Let's see what I get. I got a 6! I actually did get a 6. So that means that the terrestrial planet also gets rings. Everybody else, no. And no. So that's the end of moons and rings. Let's see. Distribution of moons. Okay. I'm not going to record the distribution of all the moons. I find that silly. Even though I didn't end up with a lot in this one. I've had when you get many gas giants, they can really get a lot. 5, 24, 25 plus 13 is 38 moons. And I don't want to calculate the distribution of all the moons. If you want to know how the moons are distributed, I would suggest going and reading in the book how the moons are distributed. All it's going to tell you is, I can tell you, I think actually I know, but it's a little complicated. You have slot. It's just telling you how far away from the planet is the moon going to be, and for small moons, you have an interval of 10,000 kilometers. So the first small moon would be at 10,000 kilometers, the second small moon at 20,000 kilometers, the third small moon at 30, and so on and so forth. Medium moons are going to be at intervals of 50,000. So at 50,000, second one's going to be at 100,000, so on. I believe large has an interval of 250,000, and then giant is 500,000. That's all easy enough. The problem comes when they intercept. So let's say you have 5 small moons, and 1 medium moon. And that's all you have. Then that's not going to be too difficult. You have 1 small moon at 10,000, 1 at 20, 1 at 30, 1 at 40,000. The medium moon will be at 50,000. The 5th small moon will move out. The smaller of the two will move out in the interval of the planet that it's intersecting with. So in this case, a medium moon, meaning it gets an interval of 50,000. So the next small moon would be at 100,000. All right? And then, say if you had a large moon, no, wait, the larges are at 250. So if you had a second medium moon and intersected that one, it would move another 50,000 out, and you keep moving the smaller ones out until they find a free spot. And that's basically how moon distribution works. It's not important for anything unless you want to go and visit the moon, in which case I suggest, figuring it out then. That's all I'm going to say about moon distribution. Again, if you didn't understand what I said, which is understandable because I just blew through it, go read in the book. Moon distribution is on page... Size of moon, distribution of moons. It's on page 107. So just go read about the distribution of moons. It's it's all there. That brings us to calculate gravity, and that we're going to save for the next video, where we're going to be calculating a whole bunch of data according to what we just rolled today. All right, so it's going to be, we're going to do the gravity, escape velocity, year length, escape velocity modifier terrestrials. So that's going to be really the math heavy episode, I think. So thanks for joining me. I hope to see you in the I hope you join me in the next episode. And I hope it's all not too complicated so far. Yeah, thanks for watching. Bye-bye.